Welcome to ClueCon Weekly. Join us every Wednesday to learn about the latest cutting-edge developments in the real-time communications industry. ClueCon Weekly is brought to you by FreeSwitch Solutions. Get support and professional services directly from the creators of the FreeSwitch open source project, solving your issues in the most efficient, stable, and scalable way possible. Get the FreeSwitch advantage. Visit freeswitch.com. Also brought to you by ClueCon, the premier technology conference for developers by developers. Join us every summer in Chicago. ClueCon kicks off on Monday with our annual hackathon, The Coder Games, followed by 3 days of technology-rich presentations discussing telecom, WebRTC, and IoT from developers around the world. To learn more, visit ClueCon.com or call 877-74-A-CLUE.
And welcome to ClueCon Weekly. Today is the 13th of March, 2019. This week we're going to be joined by Alan Percy from Telco Bridges. Alan's going to be talking about FreeSBC. So you guys want to stick around for that and see what he's got to talk about today. First, let's jump over and see Miss Abby for the news. Abby, how are you doing today?
I am doing wonderful today. Thank you for asking. Hi, everybody, and thank you, as always, for joining us today on ClueCon Weekly. I have a bunch of announcements, so hang in there, but they're all very exciting, I promise, so make sure to listen up. So you can come chat with us in our new ClueCon community channel at signalwire.community, and that's our new ClueCon-only Slack channel. So while we do have SignalWire and FreeSwitch Slack channels, if you have any technical questions or you just want to say hi, we also have a new ClueCon Slack channel for everybody to talk about ClueCon, ask us some questions, give us your ideas, so make sure to go check that out. Our call for speakers for ClueCon is also now open, so don't forget to submit for that at ClueCon.com. It's really easy to find where to submit. It's right at the top of our homepage is a link, and we really want to see you speak, so don't forget the due date for that is in 1 month, so get on it. We want to hear what you have to say. More ClueCon news is that we have 2 new tickets that we have not offered in the past. We have a brand new Coder Games only ticket at $99 and a family ticket for $250. So of course, if you are going to ClueCon as normal, you register for the whole week. The Coder Games, which is our hackathon, is completely included. But if you or somebody that you know is interested in showing up only on Monday for the Coder Games, we now have an option for that. In FreeSwitch news, tomorrow is our next virtual FreeSwitch training. That's March 14th is tomorrow. And you can sign up for that still at freeswitch.com, or you can email Sharon at freeswitch.com for more information if you are interested in learning more about that. And it's not too late to sign up, so don't worry. A shout out to FreeSwitch's sponsor, SignalWire. They are currently offering $50 in credit if you use the code CCWeekly19, all caps, CCWeekly19, to purchase phone numbers, DIDs, things like that, and to play around and see how you like it. You can sign up for a space at signalwire.com, and I promise that $50 will last a long time. Another sponsor thank you to Telco Bridges, who is joining us today on ClueCon Weekly, for sponsoring ClueCon this year at our 15th anniversary. We are so grateful to you guys. If you guys aren't aware, you'll learn a lot more in a couple of minutes, but Telco Bridges designs and manufactures quality, high-performance telecom equipment. They help carriers benefit from their current system infrastructure, facilitating seamless TDM to IP communications and allowing for the deployment of next-generation value-added services. They do remote and on-site installation, personalized 24/7 support, and yeah, so they're gonna teach you a lot more about that in a couple of minutes, but I thought I'd give them a good shout out because they are sponsoring ClueCon, and we're so grateful for that. If any of you are attending Enterprise Connect coming up pretty quickly, you should look out for some of our team members because some of our team members will be roaming around. We don't have a booth at Enterprise Connect, but we are attending. So make sure to look out for us and say hi, or you can message us on like Instagram or Twitter or our Facebook, our FreeSwitch Facebook, if you want to find out where we are, and we'll tell you and you can come say hi. And as always, last announcement is that if you have any questions during this call, if you have a question that you'd like us to answer live, you can ask those on the Slack channel, in the YouTube channel, and we will answer them during your call. All right, that's all I have to say for now. All right, and back to you, Jersey Mike, I think.
Here. All right, yeah, let's just jump
Hi,
on
guys.
over
Happy Wednesday.
Mike and Alan.
Okay.
Hello. So, Alan, thank you for coming in today. Tell us a little
my
bit about
pleasure.
Telco Bridges.
Sure. Well, we're going to learn a little bit more about some of the products we're going to talk in today's presentation, but just a little bit of background. The company was founded in 2002. We've got about 45 employees up in Montreal, and they have been building media gateways and signaling gateways for the big service providers for most of their time. And we're going to talk today about our FreeSBC initiative, which was kind of a spin-off from the core of their business group that was started just a little over a year ago, which is when I joined the company. So hopefully sharing a little bit about what we've been up to and some use cases and customer examples and some really neat stuff today, including a little bit teaser about something coming up with Stir Shaken. And for those of you that are in the service provider side of the business, Stir Shaken is going to make a big change in how calls are handled, including our topic before we got started, right, about robocalls. So we've got lots to share today.
Okay, great. So let's get started.
All right, very good. So why don't we do, I guess, a screen share here. Ken, if you could put me up. There we go. Great. All right. Well, let me just start out with a quick introduction. I think many of you folks have had a chance to run into me various places around in the industry, and I obviously appreciate communicating with you. I've obviously got a couple social connections here, but one thing I wanted to share with you too, in addition to my joining Telco Bridges last year, was we just started this new podcast called Telecom Disruptors, and I know this community is loaded with disruptors. I think this is basically what this community is all about. And what we're doing is we're picking up stories about the development and the changes of the telecommunications industry. And if you think you've got an interesting story you'd like to share with me, I'd love to have you join me as a interviewee. But I also too, I've got some great stories about the early days of voice over IP, where I was able to catch some of the original inventors. So definitely check that out. And one other note before we move on too, by the way, I am going to be at Enterprise Connect next week and would love to meet you folks face to face. Use any one of the social or email platforms to get a hold of me. I'd love to touch base with you while we're at the event. All right, so I gave you a little hint about Telco Bridges, and I think some of you folks probably, I'm guessing a lot of folks have probably not crossed paths with the company because it's been primarily focused on the big service providers until recently. But as I mentioned, it's about 45 people based in Montreal, and one of the unique things about them is they do have a real good, solid support infrastructure based in not only Montreal, but in Hong Kong and Turkey and in Poland, and they can provide 24/7 technical support for across their product portfolio. So it's a very well-established company that's got a good, steady revenue stream that has kind of decided to step out and try something different, which is what we're going to talk about today, which is the FreeSBC and session border controllers. So I want to spend a couple of minutes to talk about some of the risks that are occurring in the network, and I think many of the participants around this are aware of some of this, but just kind of reinforcing it. First of all, one of the big risks that we're seeing with telephony service providers is based on a couple of motivations. One of them is certainly extortion, right? I'm sure you've all gotten the emails threatening you. They've broken in your email box, which is in reality they haven't, or they're threatening to swamp your telephony application with denial of service attack unless you pay them a certain amount of Bitcoin. This kind of an extortion attack seems to be on the growing path and becoming more and more common. And that kind of has another sister, which is intrusion, which is where they're trying to probe your network to find devices that they could then attack and or possibly break into and collect some data, which then would give them either some data to sell, or credit card numbers, or possibly IP addresses of sensitive areas that somebody else could attack. And of course, all this is wraps up with a third leg, which is the theft of services. And this is probably one of the worst financially impactful ones, which is where some platform could be FreeSwitch, Asterisk, any switch, PBX, anything that can make telephone calls are being used either illegally to make telephone calls or used to call premium numbers and drive up huge telephone bills. And we're starting to see that happen more and more. And matter of fact, we just came with an example here, which is this poor gentleman, Bob Foreman, his architecture firm in Georgia a few years ago, went home one weekend, came in the morning on Monday and found out that his telephone system had been hacked, and that it had made 166,000 calls to a premium number overseas over the weekend. And unfortunately for him, he was stuck with a bill. And I know a lot of you folks are operating either hosted or enterprise-based IP PBX platforms, and you can imagine the distress that this would cause this small business. But also, for the service provider, it causes all kinds of problems, because while they act as a financial arm to make this happen, they end up all entangled in a legal fight a lot of times, and it's just not a good situation for everyone that's involved. And it's a bad case that we all need to figure out a way to stamp out these kinds of fraudulent theft of services kind of attacks, and they're happening more and more. So today we're going to talk about SBCs in open source, and we're going to spend a little bit of time just talking about what is a session border controller. And I know many of you probably are aware of it. We're going to talk a little bit why I need them, and then what do they do, and then we're also going to talk about what do they not do, and we're going to talk about some use cases, deployment models, and some really neat things that started to come up, including, as I mentioned, stir shaken, and how that can be implemented using session border controllers. And we'll wrap up, of course, where you can learn more about this whole thing. And of course, as always, I'd love to, your questions or comments. You can go ahead and drop them in the chat window here. And let me just double check, make sure I got that open here. And I'll try to keep an eye on that so we can, if questions pop up. Okay. So I like to tell this story based on, I don't know if you folks would suspect some of you are craftsmen, but I too have a workshop and I've done some woodworking, and I know too well that in many crafts, whether they're woodworking or metalworking or building cars or whatever it might be, that having the right tool is critically important. And not only having the right tool, but knowing how to use the tool. And this is no different than what you folks do with your communications solutions. When you design and build communications, you need to know what all the tools that are available at your disposal, and to make the right choice, use the right tool. And while you could certainly use a screwdriver to pound in something that's really not the right thing, using a hammer is obviously the right tool. And making sure you have the right tool for the right job, and time saving too. And we're going to talk about how SBCs in some cases can be the right tool. A standalone SBC can be the right tool. So, all right, I'm assuming most everyone here is pretty familiar with SIP. Just a couple things I just want to remind most folks about. Is that the specification for SIP continues. Matter of fact, I was talking to Alan Johnston and John and Jonathan, the developers of original SIP, and the kind of one of their regrets is that they left it so open that the looseness continues to cause these interoperability issues. And the separation of the call control and the media, while it comes in handy, sometimes can cause problems, right? And I think you all know that. And the verboseness of SIP, and especially cases like where there's been a large wide area power outage, and suddenly the power comes back on, and there's 10 or 15,000 IP phones that want to re-register back into the registrar. And not only do they want to register, they want to set up all their subscriptions. It can be very, very verbose, and these are kind of, some of the challenges that go along with SIP. But there's the parts of the platform we can address this, and we'll talk about that as we go along here. Also, too, I think just to take it's worth spending a moment on the OSI model and talking about where the different elements of the network can, because I think sometimes people forget where the various pieces of the communication system fit. And I think you all know network switches are very definitely physical data link layer down at the bottom dealing with connectivity. Firewalls and routers are generally responsible for the network and transport layer, making sure that the right packet gets to the right destination, but not responsible for the other elements that go above. And this is where SIP proxies start to fit in, about delivering messages and having some session control over the application, but not really focused on the media necessarily, nor actually on the delivery of the application to the user. Whereas a session border controller really culminates a broad spectrum of the network OSI model, and handles not only some of the lower layer components of the firewall and router, but also manages the presentation and application delivery at the very, very top. So this is kind of puts things in perspective of the span of responsibility for a session border controller. So in a nutshell, what is it? So a session border controller, sort of by definition, is a software element that sits between two different networks. It's generally being deployed between a wide area network and often a local area network. Where these two networks intersect, it's generally owned by one side or the other, and is used to protect and create resolve interoperability issues between these two networks. Generally, it's considered to be a security element, but interoperability is a key part of its functionality. And so we're going to get into some specifics of what's inside here. And I think that it's pretty well understood that the architecture within the session border controller kind of fits into this general model here that I've put up, which is where there's two kind of inputs over on the left here. There's a SIP session, which is the session control part of SIP, and again, this is the the signaling part of the messages. And there's also the RTP, the media that would go into a session border controller, using a back-to-back user agent to terminate this session on a user agent server, deriving state and message requests down to their kind of atomic requests, and then reestablishing another session within this trusted network on the right, using a user agent client and a routing engine to then deliver those messages off the various SIP applications. So you can imagine, for example, let's say it was a conferencing application that's on the right-hand side. You might have multiple servers managing a conferencing application. When a request comes in from an external user, not only is there SIP session routed off to the application, but and the media is routed off to the appropriate application server, but also they're given new private IP addresses for both the session and media. And this is the big difference between some of the other things that are out in the market. The advanced SIP proxies that are out there, is the total termination and reestablishment of IP addresses with the back-to-back user agent and the corresponding media engine, making sure that none of those private LAN IP addresses are exposed to the outside world, and that the outside world only sees one or a set of public WAN addresses to provide that insulation. So just a quick overview, and there's obviously a lot of little moving parts, but this we figured it would be a good way to just explain at the very high level what's going on. So a couple key things: the back-to-back user agent, the media engine, and the routing engine are all key pieces of the session border controller. All right, so how does it typically deployed? We're seeing it in many cases being deployed on a trusted network behind an external firewall. their existing firewall, usually with some kind of using a tunnel to redirect certain either TCP or UDP port numbers over to the session border controller, and then being processed by the SBC to deliver calls off the call servers. And this has the benefit in this particular case of having either a singular or single set of wide area network IP addresses that are exposed, and the firewall performing the initial filtering of the packets before they get into the data side of the network or before they get over to the SBC. More common, we're starting to see this model, which is where within service providers are putting their voice applications behind an SBC. That's a combination of a firewall plus the session border controller functionality, separating their voice traffic either with a VLAN or a separate IP address or separate physical network on the outside, delivering the services into a trusted network in the core. And this has the benefits of spreading some of the load out, keeping some of the voice traffic out of the data firewall, and having then a firewall that's specifically focused just on the voice traffic. And this is, as I mentioned, becoming more commonly used in service provider applications where they're using separate networks for their voice and video traffic. Just a quick comparison.
That's pretty good, because what you end up doing is
Yep, go ahead.
I was going to say that's great, because what you do is you pull the firewall out of the equation there.
Yes, you do. And matter of fact, some of the other session border controller vendors try to remote control the firewall using APIs. We made a decision just to put a standalone session or standalone firewall as part of our SBC package to separate that out, so a little bit more efficient. Okay. So just a quick summary of the functions within the network. Certainly, as we discussed, firewall is all about packet, the lower level packet filtering, and the front end protecting it for DDoS attacks. Proxy adds a few more functions with its responsibility with the SIP header manipulation and routing. But a session border controller adds a whole lot more, right? Fraud protection, topology hiding, potentially blocking robocallers with and using implementing stir shaken, which we'll talk about. Maybe QoS management, measurement and reporting. Maybe potentially media transcoding or transcription, and then dealing with media denial service attacks, which to manage. So let's get into some of the functions. We've already talked about this topology hiding a little bit, but just to kind of reinforce this is a key role for the session border controller, right? The IP address translation from one side to the other, but it goes even deeper than that. It's not only just hiding the IP addresses, but there's information sometimes that are in those SIP messages, right? Capabilities, for example, supported codecs and about timeout messages and other things like that you may want to have different on one network than you would have on another network, or you would not like to expose that information. In many cases, that's because you want to keep, what are the applications that you've got inside your private network private. You don't want to necessarily expose your list of vendors to your external customers and or what their capabilities are. You'd like to keep that secret. So the back-to-back user agent, and again, all the call control of the media is hidden, with a back-to-back user agent in the application side. The denial service, intrusion prevention, this comes from a couple different places. Obviously somebody trying to intrude or attack your network with, brute force attacks, or maybe they're using bots that try to get at and overload the network. One of the key things the session border controller can do is very high speed traffic deflection. And this is one of the really common use cases, using call rate limiting or message rate limiting to block some of this traffic, so that SBCs generally have an algorithm in there where they look at the origin of the traffic, and they look at the rate at which they're coming, and they can deflect that traffic before it ever gets into the private network. And the key thing is that software has to be able to keep up to these DDoS attack messages, to the pace at which they come, and it's in the speed of that, and the efficiency of that session border controller is critical to be able to deflect those. And this is a kind of a differentiator between a dedicated session border controller versus reusing something like for FreeSwitch, for example, and turn it into a session border controller. Is the speed and pace at which it can keep up with these messages. So this is a key function, blocking those messages before they get any further. Another area is encryption demarcation. It's pretty common now for a lot of the applications who want to have an encrypted not only media but session control out in the when it goes over the internet. But you'd like to have it as in the clear when it gets inside your data center. And session border controllers are often used for, we call it transcription, right? Which is either going from encrypted to clear or going from one encryption key to another encryption key, and re-encrypting the packets with a different key as it passes across the network border. And this function, again, we're seeing more and more as these applications are moving to the internet. And what it does, it makes it much more efficient for the application servers because they don't have to do any decryption. They've basically offloaded all that responsibility to the session border controller. And this lets those application servers scale much, much higher because they don't have to do all that processing as they go. So that's another application. NAT Traversal, this is very common also, which is where there'd be a small, medium enterprise at a remote location with maybe a collection of IP phones and a router that is going to set up NAT. So there's a private IP address on-prem, and the service provider's got some kind of application, and they would like to have keep a NAT, be able to traverse that NAT. And do all that pinhole maintenance to keep those pinholes open, and session border controllers are used very commonly to do this. As a registration were to come in, to just keep pinging that IP address to just keep that NAT open and allow the application to initiate messages back out to the enterprise. That without the SBC, the NAT would close. And the pinhole would close, and of course then the application wouldn't be able to then ring a phone out of the enterprise. And this kind of pops up in architectural designs. We also talked about manipulating some of the media. There are many cases where transcoding needs to happen, where one service provider uses one particular codec and another either uses a different, or maybe an application needs a different one. If I was dealing with a customer just yesterday on this particular topic, their application uses speech recognition, so it uses G711, and the service provider in Brazil likes to use G729, and they need to do this transcoding, and they need to do it very quickly. The minimize any latency contribution to the transcoding is very important, and they need to do it at a very large scale, tens of thousands of sessions simultaneously. And that kind of scale is difficult to reach without a lot of processing power. Other little pieces too, as part of the media services, is doing call recording, where you would be able to create a copy of a conversation and forward it off to law enforcement. And those of you in the service provider market know that this is a CALIA requirement. The requirement by the law enforcement agencies like the FBI to be able to ask for, with a court order, to ask that calls are forwarded to one of their recording servers. And on contact centers and other applications, they do recording for, for quality management purposes, et cetera, et cetera. But also too, this is, since you're touching the media, this is also a real good place to do some quality measurement. So you can use MOS quality service scaling to come up with a gauge on how well how much voice, the quality of it, and what kind of packet loss there is, and and be able to then look for anomalies in the network, and maybe there's a router that's overloaded or there's a network link that needs to be upgraded, and do that voice quality measurement and kind of scope out problems before people start to complain about them. And certainly SIP interoperability. We chatted about this a little bit earlier, but you know, being able to resolve disconnects, and you would be amazed the number of little tiny little quirky little things that SBCs are used sometimes to solve. Little things like, you know, fixing the dial plan, like this first one with the digit manipulation, where, you know, people dial with 7-digit numbers, but for the particular application, you need to put the area code and the +1 in the front of it, to hiding some of the user information. For example, this privacy notification, changing the name from Alice to anonymous. Manipulation in the headers. We run into this all the time, where there's a little tweak here or there. One particular situation, the customer couldn't handle fully qualified domain names. They needed to have hard IP addresses, and so the SBC's job was to just do that conversion. In other cases where they're doing different flavors of SIP, from SIP to SIP-I, for carrier interoperability. So all kinds of little weird tweaks, and in some cases these have to be done at a very high pace, and very, you know, obviously cost is a real concern. And traffic management's a big piece of the puzzle too, right? Be able to spread load across different servers, sending traffic based on called and calling number, using either internal or external algorithms to be able to do call traffic routing. And perfect examples is like as you start to move your scale up and you start to get to larger and larger, let's say conferencing applications again, you know, having people who dial a particular number get routed to the server that's handling that number, and the SBC can do that load balancing and based on dialed number, for example, very efficiently, and it's a great way to do it, along with all those other things we've already talked about, you know, the interoperability, et cetera, all in a single spot. So another topic that I want to talk about that's popped up once in a while is people ask once in a while, well, you know, what's the difference between a session border controller and an enterprise session border controller? And a little sort of personal history on this. When I was working for Audio Codes, we started to talk about, you know, the SBC role in deploying inside enterprises, and we kind of came to the conclusion that there was a very different role on the enterprise side versus what service providers were buying and selling on their priorities. And I just put a quick summary here, not to go through it in terrible detail, but the big differences really were, you know, who are you protecting, right? The service provider is worried about their network, the enterprise is about their network, along with it's kind of a list of other differentiators. But one of the key things is the scale between the service provider SBC and an enterprise SBC, and how it's sold, right? The service providers tend to buy stuff through systems integrators, where the enterprises tend to buy them through channels, resellers, and channels. You know, one is not the other. It's kind of the difference between, you know, a kind of a commercial truck and a pickup truck. You know, so they're very different customers, very different uses, but they're both trucks. And so this question sort of pops up once in a while. I wanted to address that. So I thought it would be good to just cover a couple of use cases. Probably you folks are involved in some of these here. You know, certainly peering between an application that's a hosted application on the right with some kind of soft switch free switch would be a perfect example of it. We have, you know, a lot of customers doing this. They're using the SBC to drive a separate billing system, and then they're working with wholesale VoIP, one or more wholesale VoIP providers, and doing that peering, providing you know, a path for that traffic and capturing all the billing information, and providing the interoperability and, you know, protection and all the other things we already just talked about. The access application certainly, you know, that comes up with doing the NAT Traversal. This one's really popular too, which is using the SBCs to help with a redundancy strategy, in where there are multiple redundant servers on the right, like free switch servers on the right, and multiple wholesale providers. And while you could cross-connect all those providers to all those servers, there is some benefit to putting SBCs in this place to provide that cross-patching of paths between the providers in the applications. And the real big benefit is it kind of abstracts the left-hand side of the diagram, right? So what providers are you using and how do you route calls? The SBC can take care of all that. Whereas on the right-hand side, the application is just focused on, is delivering the application functionality and doesn't get dragged into all the call routing algorithms involved in delivering those services. So we've got quite a few FreeSwitch customers who are using this architecture with FreeSBC to provide this, improved reliability and deliver services through wholesale providers. Another one that's popped up more recently is using putting the SBC out at the customer prem. The service provider puts an SBC at the customer prem. And how they do that is they use a new platform called the Universal CPE, which is a combination of termination hardware, network termination hardware, along with virtualized network function software. And our FreeSBC is available as a VNF on the KVM platform and can fit in one of these Universal CPE platforms that come from Ciena, Telco Systems, RAD. There's a number of these vendors that offer these. They terminate, for example, an optical circuit, and then they have a little miniature server built in where they might put a SD-WAN software, put our session border controller software in, and in some cases they even put some application logic in there. And the reason we're seeing this happen is to manage call traffic, and especially these large contact centers that use dialers can generate tens of thousands of calls per minute. And the trick is to do a call rate limiting at the edge of the network. So you're protecting the core of your network from excessive traffic, and you can do your interoperability and all the other things, right? To protect your network from the enterprise network, all through this VNF loaded onto a CPE. And we've got one case study on our website about Macatel, a big service provider down in Mexico, who's adopted this architecture to help them protect their large fiber optic network from the customers. All right, so let's move on and let's talk about STIR/SHAKEN. And if you're not familiar with it, I'm going to give you just a little walkthrough of what it is and what it's all about and why it exists. But we all know the problem with the robocalls, and more recently with spoofing caller ID. And this is really what the root of the STIR/SHAKEN initiative is all about. What's happening today is robocallers are making a phone call with fraudulent caller ID. There's nothing stopping you when you make a call of throwing whatever caller ID number, calling number ID on a call when you throw it into a SIP service provider. And of course, with the originating service provider has to trust that you gave it an appropriate number. There's nothing stopping them from doing that. And of course, it goes all the way to the terminating service provider with that fraudulent caller ID. And the side effect of that is it goes to an end user who sees, a fake number with a fraudulent caller ID, and of course trying to sell something, right? Or trying to tell you that they're the IRS, or that your bank is calling you. Obviously, causing a lot of fraud problems, and it's a real issue. And one of the key issues with this, by the way, is it's very difficult for the authorities to figure out who made the call, because even though this diagram here shows 2 service providers, it's not uncommon for it to jump through 3 or 4 service providers when it goes to the wholesale network. And there's really no way to connect the terminating call to the originating call without going through all these call logs. So it's very, very difficult, and they only do it in a handful of very rare cases. So along comes this idea of authenticating the caller ID and adding what's called an identity token and passing it along to the terminating service provider, who could look at this identity token and then make decisions on whether or not to deliver the call to the customer. So what STIR/SHAKEN does is allow for these policy choices at the terminating. So what happens is that the originating service provider would confirm that the original caller is a customer that they know and that they're using a caller ID that they have been assigned, and would add an identity token on that call when it leaves their network. When it gets to the terminating service provider, he's going to be able to verify that identity token and then make these policy choices, which may include things like sending it to a phone capture kind of application. It could just reject the call, or it could complete the call to the customer. So this is what STIR/SHAKEN's all really about, is taking a call that from a potentially either fraudulent caller and prevent it from getting to the end consumer. So how does it happen? How does it work? We've been working with TransNexus on this solution, and let's just take a quick peek at what happens at the originating service provider. A call on the service provider, and the initiates on the bottom left-hand corner here, would go into the originating service provider infrastructure. It would use a session border controller like our FreeSBC, which then directs the call over to a authentication service who would look at the policies, and then using their secure key store would then sign a identity token and then pass that token back to the session border controller. And then the SBC sends a single SIP call with the identity token in its header out into the wholesale network with that token attached. So now that call traverses through the wholesale network, and it gets to the terminating service provider, and sort of the opposite happens, which again, the call comes in. First thing it usually lands on is a session border controller, and we shoot it over to the verification service that TransNexus hosts, who goes and looks at the certificate repository, decrypts the header, and then returns back what's called a verification status, a verstat, which is a part of the SIP header. And then that verstat is then delivered to the calling party, or to the called party, and that can either be used to drive an application that calls screening. It could show up as a verification display on their phone, or it could be it could direct a voicemail application, these kinds of things. So it's a really complicated solution. I just wanted to give you a quick second to show it as a use case for a session border controller, but we are actually hosting a webinar on April 2nd to get into the nitty gritty of this. If you're interested, we've got a registration page here at www.telcobridges.com/STIRSHAKEN-FAQ. And if you'd like to jot that down real quick, you can join us on April 2nd, where we're going to have Jim Dalton from TransNexus with us to explain this in more detail. We'll have more time to talk about it and answer your questions on how to implement this. And this is critically important for any of you that are offering hosted services. If in the next year or two, if you don't support STIR/SHAKEN, you're going to see your call answer rates plummet. If you're delivering enterprise services to customers, knowing about this verstat and this verification status and the call header may make all the difference in the world in having satisfied customers, because you'll be able to do a CAPTCHA application, for example, at the enterprise side. So definitely you might want to pay attention to this. So just wanted to wrap up with just a quick note about our FreeSBC platform. It's a full function, software only session border controller. We offer it in 2 editions. We offer it in a free edition, which has all the basics, and we have a pro edition, which has quite a few add-ons to it. And we detail all that out on our freesbc.com website. I'd encourage you to take a look at that. Of course, it's compatible with a whole wide range of soft switches and billing packages and all kinds of different applications, and our interoperability list grows every day, and these tiles keep getting smaller and smaller as they grow, as we move on. And I wanted to wrap up with just a couple of benefits. When I started to look at the free switch community and what are some of your challenges, and I just distilled them down to these couple of things here. So the real benefits we see is, first of all, the pay-as-you-grow business model of FreeSBC, with its free edition or the pro edition subscription, right? You can start out with 500 sessions for $500, and as you grow, your business, you go to 1,000 sessions, your subscription price just goes up. It's an annual software-based subscription. And that Pro editions come with professional support, 9x5 or 24x7 telephone support. It's very easy to install. We've had lots of customers call us and say, oh my God, that was so much easier than I thought, because it's a single image that when you do the install, it installs the operating system, installs the firewall, the session border control, and all the diagnostic software all in one shot. So it's literally like stick a USB stick into a bare metal server and turn it on, and it installs all the software. You can install on bare metal, VMware, KVM, and we've got versions for AWS. Lots of platform choices. We talked about performance. FreeSBC can handle up to 60,000 sessions per server, simultaneous sessions per server, call rates of about 1,100 calls per second. So it's very, very high speed, high performance. It has virtually unlimited call routing table. We've had customers do millions of call routes in our call routing algorithm. It has optional high availability with 1+1 configuration, which we talked about earlier. And lastly is the stir shaken support for compliance for the new FCC and CRTC mandates. So we think it's a pretty good fit for this community, and we've seen quite a few downloads, people saying they're going to use FreeSBC with FreeSwitch. And so thus we wanted to participate in the community. We're here today. We're going to be at ClueCon, and we're excited about it. So we'll wrap up with a couple of key websites here. Our downloads, our frequently asked questions site, and of course we've got lots more on our educational video library at freesbc.com. And with that, I guess I'm going to turn it back over for some Q&A. And I think, Michael, you were going to do that?
Yeah, absolutely. So, Alan, what open source projects do you use? Like, what's under the hood?
Yeah, so it's a good question. Well, first of all, this is commercial software. It comes with an end user license agreement, and it does use an open source operating system as part of its guts, but it is a commercial software package. It's not FreeSwitch, unfortunately. No. Yeah.
Oh.
Yeah. Yep. Yeah, to get the performance and et cetera. Actually, its origin is out of our media gateways. The media gateway platforms that telco bridges have been built over the years was really the origin of this the SIP stack and a lot of the call routing algorithms, et cetera, that are built as part of it. But it does have an open source operating system as part of its delivery. So.
Well, I mean, that's a very common structure. A lot of the platforms, like this, they're using open source software under the hood. It's just, the open source software is essentially, the tools to build upon, right? And so we provide the framework, and what someone does with that framework is really, the magical part of it.
Yep. No, and that's like I said, we see this as another tool for people's, for their workbenches. So yes.
So what were some of the challenges? You were talking about really high CPSs, like 1,000 CPSs, and 60,000 concurrencies. What were the challenges you found? Because you clearly you clearly start running into enormous barriers once you get into these like substantial call volumes.
Yep. Well,
so
probably
what were some
one
of the
biggest
you guys
had? Yeah. So I think a couple of key things is to kind of maybe use a metaphor. Some of the platforms that are out there, they're kind of like a Swiss Army knife. They could do a lot of things, but they're not terribly well. They weren't really necessarily designed to do certain functions really well. But like a surgeon's scalpel was designed for one task and done really well. And I think that the difference with some of these tools is they were designed from the ground up to be very high volume, very efficient software packages. And I think that was the biggest challenge with Telco Bridges software, is they knew they were going into the service provider market, and they knew they were going to have to do very high call volumes. And from the ground up, they built the software to be extremely efficient to be able to handle these kinds of call volumes, because they knew their target market was going to be these large-scale applications. So I'd say that was probably that, and then beyond that, it's chasing the moving market, right? SIP is a moving target, and the kinds of applications that are going to sit behind it are constantly a moving target. So trying to keep up with adding features and chasing new software applications, et cetera, is probably one of the biggest challenges for the company. Yep.
Yeah, so like we have like the whole RTC revolution, right? And so there was a relatively slow adoption, but now it's like a hockey stick. It shoots straight up. And we've seen a lot of the actual minutes start to drop because people are leveraging off of those services. What do you think is going to happen with the future of RTC, and like how does that integrate into your platform and all that stuff?
Yeah, no, it's a good question. So a lot of the applications on the user consumer side, we're definitely seeing some WebRTC and RTC applications, voice, real-time voice and video applications. At the same time, too, a lot of these applications still leverage or integrate in calling. Right, there's still a ton of applications out there that leverage the calling, and these platforms need to be able to integrate between each other. And that's where these kinds of tools fit in, is providing that connectivity between these real-time communication applications. For example, working with CPaaS vendors like Twilio, who need to be able to work with enterprises who have existing SIP trunking integrations, and they want to be able to make telephone calls that are reminders, or they want to be able to accept 800 calls into their platform so that people can call from their cell phone, or international callers, these kinds of things. So we're seeing just this blend of communication environments, because right now the future, for example, if you say, I'm just going to use WhatsApp, well, that's great, you get hundreds of millions of users that are on WhatsApp, but what about everybody else on the planet, right? Or same thing, even Skype. At some point, Skype threw the towel in and said, "All right, we'll make it so we can talk to people on the PSTN." So I think that's what we're seeing, is a merging of these different platforms together with be able to be multimodal, and we expect to be part of that merger.
Okay. Well, thank you for coming in today. It's always good to see you. I'll see you in Chicago.
Yes.
And Ken, back to you.
Actually, I got a question for Alan real quick.
Sure.
Alan, with the shaken and stir, are you guys much pickup in the market on that yet in the service provider area?
It's a great question. So last month we held basically a how-to on how to implement stir shaken, which we obviously went into a lot more detail than we talked about here. We just held a how-to for our service provider customers, and it was by far the largest webinar we've ever held by like a factor of 6 of the number of people who registered for it. And I think that the tipping point happened this last year in late November, when the FCC Chairman Pai wrote his letter to the key service providers saying that you will implement the stir shaken and you will do it in 2019. And it woke everybody up, and everyone says, first of all, what the hell is this? And secondly, how do I implement it? And this is, we've seen tremendous pickup over the last just few weeks, and lots of discussions on how to implement it, because they're kind of in a mad scramble. So.
Yeah, it'll be real interesting to see how that flushes out over the next.
Yeah, well, back when it was an idea, it was easy to ignore because no one else did it, right? But once the FCC says no, you're going to do it,
right,
that changes the rules. And like I said,
I think it's going to be a challenge rolling that out.
Yeah. So, and the key thing is going to be is, let's say, for example, AT&T's totally committed. Said they're going to implement it. They're going to do some kind of screening application on their mobile devices. Is what's going to happen, and they've stated this publicly, that they're going to have some way to screen non-verified calls on the mobile device. So as a service provider, if you put calls into the public network that don't have an identity token on them, your calls will for sure get screened. If you put an identity token on them, then they will show up at the terminating person's device, with the green check mark, or go straight through to the person's phone. So it's going to have tentacles that crawl through the industry.
Yeah, I'm real interested in seeing how that progresses over the next several months for some other reasons. I really want to talk to you more about this.
Sure.
Years.
You know how that works, guys. Okay.
So, matter of fact, I pitched a session for ClueCon to go into much more detail on stir shaking. So hopefully, I'll get the thumbs up, and we could talk about it in more detail.
Yeah, definitely. That would be super, super cool. So before we let you go, Alan, see if there's anybody else has any questions for Alan out there. I'm gonna just check the various media sites that we have for interaction and everything.
Sure.
To see if we've got some questions here, and I don't see any, but I know we're getting toward that time of day, Alan. So thank you very much for coming to join us today. Jersey Mike, thanks for coming in and talking to Alan today. You guys don't forget, ClueCon registration is open. Go get your tickets if you hadn't got them on that. Thanks to SignalWire for sponsoring this. And don't forget, go check out FreeSBC, freesbc.com. I'm sure Alan and the rest of the guys over at Telco Bridges would appreciate that. Again, thanks, Alan, for coming in. We'll see everybody else next. Thanks, guys.
Awesome. Thanks a lot.
You've been watching ClueCon Weekly. Tune in every Wednesday at 12 p.m. Central. Keep up with the latest happenings by subscribing to our YouTube channel, follow us on Facebook and Twitter, or visit us at freeswitch.com.